Good morning everybody. In previous class we learned the histogram, frequency, polygon, frequency, curve. So we learned that one. Today class is 8th chapter, Exploring Geometrical Figures. Exploring Geometrical Figures. This chapter exercise before we remember these two topics. Yeah. Congruency of shapes. This is the move. Move means just move the diagram. Here rotate means this one is the turn the picture. Flip means mirror image. So observe these three pictures. Next, similarity means here we observe any two shapes. Shape is same, that is the similar. We observe any shapes. Suppose here two triangles, we observe the two triangles is same shape, that two triangles are similar, and shape and size is same, that is the congruency. Shape and size. Suppose these two are the same shape and size. Next, here one is the smaller triangle, another one is the bigger triangle. So these two are the similar because here shapes are similar. Here size and shape both are same. Congruency, that is the difference of similar and congruency. So you remember these two definitions. Similarity means we compare the any two objects. Similar shape, similar is called the similarity, the two objects. Now congruency, we observe the same shape and size. Same size and shape both are same, that is the congruency. So we remember these two definitions. Exercise 8.1. First question, name 5 pairs of congruent objectives you use daily. Already we know the similarity and congruent definitions and difference. So now here name 5 pairs of congruent objectives. 5 pairs of congruent. Congruence means we compare the two diagrams. Here shape and size both are same, the two are the congruent. We compare the size and shape. So both are same, that is the congruent. So congruent objectives you use your daily life. Observe your daily life. Here we write the examples of congruent objectives. Now here same size and shape are congruency. So we write the congruent objectives you use daily life. So now here first the pair of earrings. Pair of earrings. Here pair of earrings. Pair of bangles. Pair of bangles. Next, here wheels of a cycle. Wheels of a cycle. Fourth one, equal length scales. Equal lengths of scales. Next, mathematics textbook of the same class. Same class means same class, both textbooks are same. So that is the fifth one is the Maths textbook of same class. Suppose here compare you and your friend textbooks, both are same, that both are congruent. Here we compare the shape and size, that is the congruency. So simple, we remember these two. Here similarity means same shape, congruency means same size and shape. So we remember these three words. Second question, A. Draw two congruent figures. Are they similar? Explain. Here we take two congruent figures. Are they similar? Any congruent figure always similar, but similar figure need not be a congruent. So first one. Second one, take two similar shapes. If you slide, rotate or flip one of them, does the similarity remain? So here we take any two similar shapes and rotate it. Rotate after we observe that shapes that are similar or not. Now first we explain first one. Now A answer, draw two congruent figures. Are they similar? Here we draw the two congruent triangles. Here similar and congruency definition we observe this here. Shape, same shape or similar. Same shape, size and shape or congruency. So here similar, same shape, congruency, same size and shape. So now here every congruency figure is similar, but need not be every similar diagrams congruency. So now here first we take the draw two congruent figures, are they similar? Here first we draw these two diagrams. Here triangle ABC PQR, these two are triangles. So now here these two sides are equal, corresponding sides are equal. So these two triangles corresponding sides are equal. Next, corresponding angles also equal, these two angles equal. Next, these three angles are equal, these two angles are equal, corresponding sides and corresponding angles are equal. So that's why we write here triangle ABC is congruency to triangle PQR. So now here from triangle ABC and triangle PQR, ABC PQR. Now compare these two triangles. So these two triangles are, first corresponding sides are equal and corresponding angles are equal. Here corresponding sides AB is equal to P. Next BC equal to QR. AC equal to PR. These three sides are equal, corresponding sides are equal. Now next we write the corresponding angles. Here angle A equal to angle P, angle B equal to angle Q, angle R equal to angle C equal to R, both are same. Angle C equal to R. So now here the congruent triangles is similar to each other. Therefore congruent triangles are similar to each other. Are similar to each other, but similar triangles are not congruent. But similar triangle are not congruent. So now here these two triangles are congruent. Automatically these two triangles are similar. So congruent triangles are similar to each other, but similar triangles are not congruent. So this is the second one solution. Next B, take two similar shapes. If you slide, rotate or flip one of them, does the similarity remain? First we take any similar figures. So now here we take here two triangles are similar. Here X, Y, Z, similar symbol. This is the similar. These two triangles are similar. Next ST, U. These two triangles are similar. So now we are rotate these triangles also similar, rotating after. Next here these three sides are equal. So that's why here rotated, that after figure also equal. Next here we take the square. Here square means four sides are equal. So next same square we rotated 45 degrees. So rotating after this picture also equal. So these two are the similar. So we write the from figure triangle XYZ and triangle STU are similar triangles if these triangles are rotated even they are similar to each other. Even they are similar to each other. Your first these two pictures are similar. After rotating after also these two pictures also similar. That is the second one answer. Next third question. If triangle ABC is congruent triangle NMO, name the congruent sides and angles. So here these two are congruent means corresponding angles and sides are equal. So we write that one. I am already draw here two triangles. So these names are ABC, NMD. These two are congruents. These two triangles are congruents. So from the congruent triangles, Here two triangles are congruent means we write ABC triangle. ABC is congruency symbol, triangle NMD. Now here we write the congruent sides and angles of these two triangles. So corresponding sides and the angles are equal. So here AB equal to MN. AB equal to MN. So now here we write AB equal to MN. BC equal to MD. AC equal to ND. AC equal to ND. These three sides are equal. So again we write the angles. Angles also equal. Here we write the angles. Angle A equal to angle N. Angle B equal to angle C. Sorry, M. Angle B equal to angle M. Angle C equal to angle B equal to angle M. Angle B equal to angle M. Angle C equal to angle D. So now here corresponding sides and angles are equal in these two triangles. This is the third one, complete answer. Next, fourth one, state whether the following statements are true. Explain with reason. Here first one, two squares of sides 3 centimeters each and one of them rotated through 45 degrees are congruent. So here two squares of sides 3 centimeters each and one of them rotated through 45 degrees are congruent. Now here first we take two squares. Here square, this is the 3 centimeters. Now rotate 45 degrees. 45 degrees after side size is same, 3 centimeters. Square means 4 sides are equal. So now here, so this is also congruent. So because does not change the shape and size. So that's why these two are equal. So first we write the answer true. If the square is rotated 45 degrees, then it is remaining congruent. So this is the reason of this congruent. Next, second one, any two right triangles with hypotenuse 5 centimeters are congruent. So now here we take the two right angle triangles. Here two right angle triangles. One is the right angle, hypotenuse is 5 centimeters. Next we take the another triangle also same. Here hypotenuse is 5 centimeters. One angle is right angle. So automatically here these two hypotenuse are equal. One is the right angle. Automatically these two sides are equal. These two sides are equal. So now here true. If the hypotenuse of two right angle triangles are equal, then two triangles are congruent to each other. You are asking congruent to each other. Here three sides are equal means automatically three angles also equal. So here these two triangles are congruent. Now here third one, any two circles of radius 4 centimeters each are congruent. So 4 centimeters means here radius 4 centimeters, and that means equal size. These two are equal size. Radius is equal. These two circles are equal. Automatically congruent. So true. Since they are having equal radius. Equal radius, R1 equal to R2 equal to 4 centimeters. Now given circles are congruent, same size and shape are same. So therefore the given circles are congruent. Next, fourth question, two equilateral triangles of side 4 centimeters to each but labeled as ABC triangle LHN are not congruent. Here asking not congruent. Not congruent. These two equilateral triangle means automatically congruent. So this statement is false. So first we take two triangles ABC. Next one LHN. These two triangles of side 4 centimeters. First equilateral triangle means three sides are equal. Equilateral triangle means three sides are equal. These three sides are equal. These three sides equal. These three sides equal. Here side of 4 centimeters each. If each side is 4 centimeters means these two triangles sides are 4 centimeters. Automatically these two triangles are congruent. So but here given not congruent. So this statement is false. So now we write here given triangle ABC is congruent to triangle LHN. So the statement is false. Statement false. Next, fifth question. The mirror image of the polygon is congruent to the original. You take any polygon. Suppose triangle. We take this is the mirror image. So these two are congruent. So the statement is true. Always the mirror image of polygon is congruent to the next fifth question. Draw a polygon on a square dot sheet. Here also draw it a congruent figures in different directions. Here first we draw the one diagram, next we draw the one congruent diagram. Here and mirror image of it. We draw the another diagram with mirror image. First we draw the one diagram, that congruent diagram and mirror image. Here draw a polygon on a square dot sheet. Also draw its congruent figures. First these two are the congruent figures. These two squares are congruent. So congruent figures in different directions. So and mirror image of it. Now here mirror image. This square mirror image is this one. So now here this is the mirror image of first diagram. So this is the answer. These two are the similar. Next, sixth question. Using a square dot sheet or graph sheet, draw a rectangle and construct a similar figure. Here find the perimeter and areas of both and compare their ratios with the ratio of their corresponding sides. So here first we draw the square dot sheet or graph sheet, draw a rectangle or construct a similar figures. We draw the similar figures means here shape is similar but size not same. So find the perimeter and area of both. Here we find the compare these two perimeters and compare their ratios with the ratio of their corresponding sides also. Now here using the square shape dot sheet and graph sheet, draw a rectangle. Here construct a similar figure. Similar means here shape is same, that is the similar figures. So these two are shape is same, these two are similar figures. So here 4 centimeters, 2 centimeters. Now here 2 centimeters, 1 centimeter are the measurements. These two are similar figures. Find the perimeter and areas of the both. So now here first we find the perimeter and area of both. So now first here we write the ABC D. Here A dash, B dash, C dash, D dash. These two are the similar figures. So similar figures, not congruents. You observe carefully. Similar figures. Now here we compare the perimeter and area. So first we find the perimeter. Here perimeter of ABCD by here ratio of their corresponding sides. Here ratio also. So now here ratio means we divided the perimeter of A dash, B dash, C dash, D dash. Now here perimeter of this first rectangle is here 2 into L plus B. Here 2 into L is the AB plus BD. AB plus BD. By here perimeter of A dash, B dash, C dash, D dash is equal to 2 into A dash, B dash plus B dash, D dash. So now here this is the perimeter. So write the measurements. Here 2 into AB is the 4 centimeter, BD is the 2. 4 plus 2 by here 2 into 2 plus 1. So that equal to here 2 into 4 plus 2 6 by 2 into 3. Here 3 ones are 3. 2s are here 2 to get cancelled. So 2 by 1. So now your ratio is equal to, we write 2 is to 1 is the ratio. This is the both perimeters ratio. Now here we find the area. Area ratio is here area of ABCD. Here area of ABCD by here area of A dash, B dash, C dash, D dash. Here area is the product of sides. So now here area formula is the 4 into 2. Here length and width by here AB dash into BD dash. So 2 into 1. So 4 2s are 2 to get cancelled. Here 4 by 1. That equal to, we write the ratio form 4 is to 1. This is the area of these two rectangles. Area is 4 is to 1. Perimeter is 2 is to 1. Now we compare the lengths. Here length of ABCD by length of length of A dash, B dash, C dash, D dash. Here length is the 4 centimeters by length of this one. So that is the 2. Here 2 ones are 2 2s are. Here 2 by 1. That is, we write the ratio form 2 is to 1. This is the ratio of lengths. Here we write the ratio of perimeters, ratio of area, ratio of lengths. So this is the sixth one complete answer. Next, seventh question. 7 pillars are used to hold a flat iron girder as shown in the figure. If the distance between adjoining two pillars is 1 meter and height of the last pillar MN is 10.5 meters, find the height of the rest of the pillars. So now here one figure is there. Here girder. So iron girder. Here total 7 pillars are there. 7 pillars. MN is 10.5. MN here height is 10.5. Now here we find the remaining pillars height. So we find these all pillars height. Here the adjoining two pillars is 1 meter. Here adjoint pillars is 1 meter. These A to C distance is 1 meter. C to D, E is 1 meter. E to G is 1 meter. So these any two adjacent pillars distance is 1 meter. So these all pillars distance 1 meter. So that's why we find the pillar. These are pillars height. Easily we find these are pillars height. Here distance, any two pillars distance is 1 meter. Here these two pillars 1 meter. So here total 7 parts are there. Here total 7 parts are there. Here 1 meter, one distance is 1 meter. Here total 7 meters. So now here we find the remaining pillars. Now here height of first pillar. Here height of first pillar is equal to here AB. Height of first pillar is equal to AB. Here AB is equal to complete 7 meters. 7 meters. So here O to A is the 1 meter. O to A 1 meter means here 1 by 7 into here 10.5. So now here 10.5 meters. Here 7 ones are 7 7 5s are 35. Here point we write 1 digit before, that equal to 1.5. Here meter is the units. Here first pillar height is equal to 1.5 meters. Now same method we find the next pillar's height. Height of second pillar. Here height of second pillar is CD. CD is equal to here O to C. O to C is the year to year 1 meter, year to year 1 meter, 2 meters. O to C is the 2 meters. So 2 by here total O to M is the 7 into 10.5. Here 7 1 is 7, 1.5. Here 2 into 1.5 means 3 meters is the second pillar height. Here same method we find the remaining pillars. Now here height of third pillar. Third pillar is the third pillar is EF. EF is equal to here 3 by 7 into 10.5. Here 1 is 1.5. 3 into 1.5, 4.5 meters. So third pillar height. Next height of fourth pillar. Here fourth pillar is the GH. GH is equal to here 4 by 7 into 10.5. Here 4 by 7 into 10.5. Here 1.5. 1.5 into 4. 1.5 into 4. 15 4 is 60. 60 means here 0.1 digit before. 6 meters is the fourth pillar height. Now we find the fifth pillar height. Height of fifth pillar. Here fifth pillar is the IJ. Here 5 by 7 into 10.5. Same method here 7 1 is 1.5. Here 5 into 1.5 is equal to 7.5 meters. Now height of sixth pillar. Here sixth pillar is the KL is equal to here 6 by 7 into 10.5. 1 is 1.5. 6 into 1.5 is equal to here 9 meters. Here total 6 pillars are there. So we find the 6 pillars height. This is the complete seventh answer. Next, eighth question. Standing at 5 meters apart from vertical pole of height 3 meters, Sudha observed a building behind the pillar and found that tip of the pillar is in line with the top of the building. If the distance between pillar and building is 10 meters, estimate the height of the building. So here we find the building height. Here standing at 5 meters apart from a vertical pole of height 3 meters. Here vertical pole height is 3 meters. Standing at here 5 meters. Here apart from vertical pole of height 3 meters. Here vertical pole height is 3 meters. Here distance is 5 meters. So Sudha observed a building behind the pillar. Here behind the pillar and found that tip of the pillar is in the line with top of the building. Here one building is there. This is the top of the building. If the distance between pillar and building is 10 meters. Here pillar and building is 10 meters distance. So this distance 10 meters. Estimate the height of the building. So here estimate the height of the building. Now here we observe the diagram. Here DOC and BOA. These two are the triangles. So these two triangles are similar. These two triangles are similar. So corresponding sides also similar. Now a triangle OAB is similar to triangle OCD. A triangle OAB is similar to OCD. These two are similar triangles. So the corresponding sides of similar triangles are in a same proportion. So that's why we write the ratios are equal. These sides ratios are equal. Now here these sides ratios are equal. That means here OA by OC, OA by OC is equal to AB by CD. AB by CD. These two ratios are equal. So we substitute these values here. OA is equal to 5 meters. OC is equal to here 5 plus 10, 15 meters is the OC. OC is the 15 meters is equal to AB. Here AB is equal to 3 meters by CD. CD is the here height of the building. CD is height of the building. We don't know that value. We write CD. Now here we write H. So now here 5 1s are 5 3s are 1 by 3 equal to here 3 by we write H or CD H. So now here H is equal to here H carry to left hand side. Now 3 carry to right hand side. 3 into 3 that equal to 9. Here therefore H is equal to height of the building, height of a building, that equal to 9 meters. 9 meters is the height of the building. This is the complete 8th question answer. Next, last question, 9th question. Draw the quadrilateral of any two measurements. Construct dilation of scale factor 3. Measure their corresponding sides and verify whether they are similar. So now here first we use the dilation of scale factor 3. We draw the quadrilaterals, two quadrilaterals. So now comparing the corresponding sides, whether they verify whether they are similar or not, we compare these two quadrilaterals. Now first we take the graph sheet. I am already draw the axis and units. So now here first we draw the square in side unit 1 unit. So first we draw the one square. Here side is the, each side is here 1 unit. Here 4 sides. This is the ABCD square. So each side is 1 unit. Here 1 grid is 1 unit. So here A to B, B to C, C to D, D to A. 4 sides are 1 unit. So now here next we draw the lines on here origin to here B, origin to D. Next here origin to passing through the diagonals, we draw the another line. Next third one. Here origin to here vertex B. Now here this point to we touches the 4 vertices. So first one here vertices D to O, O to A, C and O to B. Now here to O to D is distance. First we find the O to distance. Here O to D is here O to D 2.3 is here in the question factor of scale factor of 3. Here scale factor of 3. Now here we measure the lengths OD, OA, OC, OB. So first here OD is the 2.2. So here 2.2. Here 2.2. Here OD equal to 2.2. Here 2.2 into 3 equal to here 6.6. Now here we measure here O to 6.6. Here O to 6.6. Here 6.6. Here O to 6.6 and mark the point. Here this is the point. So now next here OA. Here OA is equal to 1.5. Here 1.5. Here OA equal to 1.5. So 1.5 into 3 is equal to 4.5. So now here we measure on this line here 4.5. Here 4.5 to here. Now this is the point here. The next point. Next here OC. We measure the OC equal to OC. Here OC equal to here 2.8. 2.8 into 3 is equal to 8.4. 8.4. So now here we measure to here 8.4. So now here 8.4. Here this is the point. Next here OB. OB is equal to now here measure OB is the 2.3. 2.3 into 3 equal to here 6.9. Now here we measure 6.9. Here 6.9. Here. So now here add these 4 points. Here add these 4 points. So now this is the diagram of 9th question. Here scale factor 3, dilation scale factor 3 diagram. We take the square, here 1 unit square. This is the dilated scale factor 3 diagram. Now we write the matter. I am already write the matter. Observe the following dilation ABCD. It is a square drawn on the graph sheet, all vertices ABCD. First we draw the ABCD diagram or joined from the sign O. So add the ABCD to O and produce to 3 times length up to A dash, B dash, C dash and D dash respectively. Then A dash, B dash, C dash, D dash are joined from the rectangle which 3 times has enlarged sides of ABCD. Here O is called center of dilation and here OA by here O A dash by OA is equal to 3 by 1. Here 3 is called the scale factor. So now here square ABCD is congruent to square A dash, B dash, C dash, D dash. So because here corresponding sides are equal, both are congruence. Both are congruence means here 4 sides ratios are equal. So now here AB by AB dash, A dash, B dash, BC by B dash, C dash, CD by C dash, D dash, DA by D dash, A dash. So this is the matter. Next this is the complete diagram of this question. So complete this notes. Now 9th question solution is completed. 9th completed means this exercise is completed. So this complete notes PDF linked on description is there. If you are interested, copy it.